After load analysis, battery design is very important for installing the solar panel. So here the required battery capacity of an uninterrupted availability of power in ampere hour is given by the relationship. By this relationship, that is with the incidence of solar light on the panel and how much produced, how much wattage is produced and the load connected decides upon the size of the battery requirement. So battery requirement in ampere hour will be calculated by load by battery voltage. So with this help of this, the battery, suitable battery will be selected. That will be clearly analyzed in the case study. Next was the solar array design. So how much of array, calculation of array size and how much number of arrays are to be put into the system. That is very important area. So here the approximate calculation is done by means of the solar radiation that is available on that area, and with the handbook of solar radiation they will be deciding upon the total number of hours that the solar radiation is getting into and the maximum power that is got from it. With that they will decide upon the solar panels that is required. So how much power we have, first we have to arrive at the loading capacity, then with that we calculate the AC or DC separately, then we will be deciding upon the array sizing. So how much solar arrays are to be put into the panels. So average ampere hour per day is be supplied by the array. Daily average ampere hour taken from the battery, efficiency of the battery, peak array peak amps, average ampere hour per day to be supplied by the array peak sunshine power, module in parallel, array peak ampere peak per module. So modules in series, battery bank voltage nominal per nominal voltage. Battery sizing, the minimum battery capacity is specified by the daily energy requirement. 1 to 3 days of backup is generally designed. So battery will be how much amps of battery is taken up, and mainly backup for at least 3 to 4 days it will be designed upon. Then inverter capacity. Inverter capacity again, it is where the AC output is required, we have to put an inverter. So here also the standard inverters are available, and the normal wattage requirement that will be around 30% more or 3 times the capacity of the appliances the inverter will be placed. So that standard inverters ratings are available, that will be selected for the inverters. Here one case study is given during, that is for a light, 2 SCF light of 18 watts each and 60 watts each of 6 hours a day. Here a simple calculation is made up of. So total connected load in PV panel is for 2 into 18 into 2 into 60, that is around 156 watts. So total watt hours rating of the system is, it's taken around 6 hours. So 936 watt hours. Then actual power output of the PV panel is taken as, so peak power rating into the output, that is 40 into 0.75, that is 13 watts. So the power used at the end use is less than the lower combined efficiency of the system. So that is going to be around 24.3 watts. So energy produced by a 40 watt power peak power panel is around 194.4 watt hour. Number of solar panels required in such is given as around 986 by around, that comes at around 4.81, or 5 panels are required for the system. So similarly inverter sizing on it's 156 watts. So nearest sizing is 200 watts. So it's taken up as 200 watt amps. So inverter and 5 panels for the system is required with an inverter capacity of 200 volt amps. So designing a standalone solar PV system without any backup from the grid, separate solar panel system. Here one working example is given. So how it is made. So the panel is there, then put the figure, then solar array, then it's taken to the battery storage. From battery storage, again by inverter you can have AC supply. Without inverter you can use the DC current also. So direct DC current and inverter both are connected to the system. So with this they calculated, they designed around a standalone PV system. So it's can just go through the system and it's easy to understand. Designing standalone solar PV power plant. A large area, so we can have this type of solar PV power plant for manufacturing power supply for a colony or village. So that type of standalone solar power plant has been designed through these dates. Then designing solar PV power plant. So what that is PV water pumping. So open well pumping system as well as submersible pumping can be done by the solar panel. So it's very simple. Just they take up a panel and a controller which converts the DC current to AC current. When it's going to be 5 HP motor, they place around 10 to 12 345 panels, 345 watt panels, and they can use an inverter and convert it and supply it to the motor, and it operates around from 8 a.m. to 4 p.m. During daytime the pump operates and the pumping action is taken up. Either the water is stored in the well or in a sump or tank, and it is utilized for irrigation. So that is a very simple method, and most of the agricultural pumps in Thiruvarur district are been operating by the solar PV pumping system, and many government gives a lot of subsidy for agriculture pumping system when they don't want this free power supply for their irrigation pumps. So now this is catching up, and most in India many solar PV pumps are being operated mainly for agriculture pumps as well as for industries. So you can just go through the sample calculations given for the solar pumping system. Thank you.